you doing? Welcome to an algebra tutorial video. In this video, we're going to be learning about horizontal shifts of exponential functions. Last one we did vertical shifts, learned how to make our function move up and down. This one we're going to learn how to take an exponential function and shift it to the right or shift it to the left. All right, so I've got a nice basic simple exponential function here. F of x equals 1, that's my starting value, and then times 2, my base to the x power. Now let's just fill in for these x values 0, 1, 2, 3, 4. What do I get back when I input these x values in? So if I put in 0 in for x, I get 1 times 2 to the 0 power. 2 to the 0 turns into 1, so I get 1 times 1. If I put in 1 for x, I get 1 times 2 to the first power, which is 1 times 2. If I put 2 in for x, I get 1 times 2 to the second power, which is 1 times 4. And the pattern is just going to multiply by 2, one more 2 every time. All right, but we're going to mix it up. We want to figure out some horizontal shifts. I'm going to get a new function here, g of x. And we're going to take this same function, 1 times 2, but instead of to the x power, we're going to make it to the x plus 1. So we're going to add 1 to the input value every single time. Let's see what we get back now. Okay, so if I put in 0 for x, we get 1 times 2, but what power is it? It's 0 plus 1, so it ends up being 1. 2 to the first power is 2, and 1 times 2 is 2. This next one, I'll write it out just to make it a little bit clearer. So I'm going to put 1 in for x into my new function. So we get 1 times 2. But this time I have 1 plus 1. Well, 2 to the 1 plus 1 power, 1 plus 1 is 2, so that's 2 squared, which is 4. So I've got 2, then I've got 4. For the next one, we have 1 times 2 to the second power, so 2 plus 1. I still have to do that little plus 1, that's what I'm adding in. Well, that's 2 to the third power, so 1 times 2 to the third power is going to be equal to 8. We see something going on here, right? 2, 4, 8, 2, 4, 8. The next one is going to be 1 times 2 to the 3 plus 1 power. Well, that's 2 to the fourth power, which is going to be equal to 16. And the next one I'll let you figure it out, but believe me, it's going to be equal to 32. It's following another 32. So what happened here? It looks like things got shifted over, right? This 2 from the first power for g of x actually went up for an input of 0. The 4 went up there. So we see kind of a shift of an alignment, right? The y value that originally went with an input of 2 now becomes an input of 1. The y value that had an input of 3 now has an input of 2. And so we're shifting everything to the x value before it. That's what this whole red line means. Everything got shifted up to an earlier x value, which is going to cause it to move right or left on the axis. Well, okay, now we played with some table, we did some math. Again, I think you'll best understand if we pull up our Desmos calculator, our graphing calculator. Go to desmos.com/calculator. I love it. They do a great job of what they're building there. It's free and available for any student. We're going to pull that up to help us demonstrate and to see some horizontal shifting happening with this particular function. Okay, here we go. We have our Desmos calculator pulled up. You can see we've got some things going on here. There's my function f of x. It's equal to 1 times 2. But instead of the x power and instead of putting x plus 1, I have x minus h. We'll get into that, but just like we used k to represent shifting up and down, we often in algebra or in mathematics, we use h to represent a horizontal shift right or left. So it's just kind of math convention right there to use h. And then I made a slider for h, so we're going to see what happens when I slide it to the left or right. It's going to play around with the graph. And then just to make things really easier to see, I added this point here. Right now it's the y-intercept, right? It's got the coordinates 0, 1. And it'll help us understand as we're shifting right or left, and the x value of our shift is going to be based on, the x value of our shift is whatever we're adding or subtracting or putting in for h into my function here. All right, so let's draw some things. Right away, we're putting h as 0, so it's just like 1 times 2 to the x power. And you can see there's my point at 0, 1, just like we did on the table over on the left there. But now, let's make h 1 and see what's happening here. So you can see it seems to have moved everything to the right. This little dot shifted to the right. Now instead of 0, 1, it's actually 1, 1. So what just happened here? Why did it shift to the right by playing around with this value in for h? It's x minus 1, right? Shouldn't it made it move to the left by subtracting? Well, if I think about this, I'm still starting with an input value. So at this point 0, it's saying, sort of like saying, okay, take that x value, but instead subtract 1 and use the x value before that, and then run the rest of the function. So really, even though x is 0, this is sort of like saying calculate the function when you have 1 times 2 to the negative 1x. Well, that's really this left value here, and so it assigns the y value for x of negative 1, it actually gives it to the x value of 0. Or in this case, when x was 1, it actually takes the y value of x of 0 and gives it to the x value of 1. So it shifted it to the right 1 unit because we made it. We wanted to take the x value before it and assign it to the next one. What if I make h 2? Now it shifts it to the right. So x minus 2 made my function go to the right 2 units. So instead of 0, 1, now it's 2, 1. And sort of this is saying, well, based on your x value, use the x value 2 units before it and give it that y value for the function. So it's calculating that and assigning there. So if I have x minus a value, it shifts it to the right depending on whatever my value is in for h. If I make h 5.4, we've shifted it 5.4 units to the right. If I want to shift it to the left, I need to have some negative values in for h. So now I've got x minus, and I'm making h negative 3. That essentially makes it x plus 3 because of the double negative. But you can see it moved my points 3 units to the left. So instead of 0, 1, now I've got negative 3, 1 for my point. And so this time it's saying, okay, take the function value 3 units ahead, but give it back to the x value at that 1. So it's sort of like shifting everything and stealing ahead and assigning it earlier. It's why it's shifting everything to the left. But hopefully, I guess if you want a simple thing to understand, to shift it right or left, we're directly adding or subtracting to my exponent. So if we have x minus some value, it's going to shift it to the right. But if I have x plus some value for h, it's going to shift it to the left. And now you have a way not only of moving our graph up and down, we have a way to move our graph right or left when we're dealing with exponential functions.